Okay, here's a triangle, and we're going to use this triangle as a proof. And this is about as easy as a proof as we can possibly get, I promise you. So you will get this, all right? And you got to tell yourself you will get this stuff, because this one's actually very, very easy. But we're starting off pretty simple. So we're given, this is not in the book. I went online to look up some people doing proofs. You wouldn't believe how many people do proofs online, and they love to show you. It's not that guy. He doesn't do any proofs. Well, he doesn't do any of these triangle proofs that we're doing right here, because I did look to see if Khan did those things. But this is some other guy. Maybe some other time I'll show you his website. I don't know. I'm sure he probably makes a bunch of them. I don't know if it's every day or not. We're going to try to prove that triangle ABD is congruent to triangle. I'll tell you what, I'm running out of room here. Let's just scooch this down. Right there. Okay, we're going to prove that that's CBD. Alright? Everybody good so far? I haven't done anything, right? So yeah, everybody's good. Alright, let's take a look at it. First thing we're going to do. Now, we've done a little bit of proofs before. Remember the first thing that we do? We take a look at the given, then we do what with that given? What's that? Put it on the triangles. Good. Okay, we mark it on our triangles. So let's see what we're given. We're given that AB is equal to CB. Now, we wouldn't have known that just by looking at it. You might have guessed, all right, but we didn't officially know it for sure unless they tell us some stuff. So AB equals CB. So what am I going to put? Put a little tick mark here, a little tick mark there. Now everybody can do that. Would you agree? Nobody's lost yet, are they? All right, good. Let's do the next part. AD and CD are equal to each other. Here's AD, here's CD, so put a couple tick marks on this one. Now we put 2 on this one because I didn't say that these 2 segments are equal to each other, did I? Thank you. I didn't say that those 2 segments were equal to each other, but these 2 are equal, these 2 are equal, and they've got different tick marks on them. All right, that's all they tell us. And what are we trying to prove? We're trying to prove that this triangle right here, ABD, this triangle right here on the left, is congruent to this triangle on the right, CBD. What do we know so far? We actually know 2 ways to prove the triangles are congruent. Do you remember the first way we learned? This was like 2 days ago. Side, side, side. Very good. Okay, so we learned side, side, side. If I can show 3 sides of one triangle equaling 3 sides of another triangle, then those triangles are congruent. Do those things that I just said right there, does it make sense to you? If I show these 3 sides equal to these 3 corresponding sides over here, then what can I say about the 2 triangles? They're congruent. You with me? All right. Do I know 3 sides of one triangle and 3 sides of another triangle? Well, I've been given 2, right? What about that third one? What about this BD right here? BD is part of this triangle, and it's what? It's part of this triangle right here. So they have to be equal to each other. And we talked about the reason for that. Do you remember what the reason for that was? I mentioned it like briefly. I don't know if you remember or not. What is it? No. There's a word. There's a word that we use. Nobody remember? Remember we said it's like looking in the mirror? Reflexive property. Nobody remembers that one? Maybe it was in my other class I said that. Okay, I know I said it in one class. Might have been the other one. But it's called the reflexive property. For instance, if I just said A equals A, right, and we're like, well, of course A equals A. That's kind of silly. That's dumb that something, of course, something equals itself. All right, just common sense. But they actually give that a name. They give this a property. They give it a name, and we call this the reflexive. Write it down. We're going to use this a lot, and this is a nice one. This is kind of a fun one when you see reflexive. You're like, oh yeah, I see that, and we use it quite a bit, and it's kind of nice. Reflexive property. I'll just shorthand it. Okay. So when something equals itself, we call it the reflexive property. We'll talk about this segment right here. BD on this triangle, talk to me, equals what? BD on this triangle. Do you agree? So would you agree that BD equals BD? Or line segment BD equals line segment BD? Absolutely. Well, what tells us that something equals itself? The reflexive property. So look what I can do. Now, it's not given, is it, that BD equals BD, but we can look at the picture. We can say, oh yeah, this on this triangle equals this on this triangle. Does that make sense? All right, so I can mark it if you want. Okay, I'll put 3 tick marks there. And you don't have to do it twice, do you? Because it's just one line. So the 3 tick marks means that BD equals BD. Now, look what we have. I've got this side equaling to this side, that's one side. I've got this side and this side, that's two sides. And I've got this equaling itself, and that's three sides. So, guess what's true about these triangles now? Side, 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 and they are congruent to each other, absolutely. Does that make any sense? That was pretty simple, wasn't it? That was an easy proof. Look, we didn't even write anything down, did we? Except for little tick marks and stuff. So now we can write a two-column proof. Now remember, the book says, on some of them it'll say write a flow proof, some will say write a paragraph proof, some will say write a two-column proof. What did I say that we're always going to do?
Two-column proof.
Two-column proof. We're always going to do a two-column proof, right? Later on, now I'll tell you, when you get to college and you get to upper level stuff, they hardly ever, if ever, do two-column proofs. They usually do a paragraph proof. But for right now, I think it's easy to organize a two-column proof. So we'll just stay consistent. We're not going to jump from one to the other to the other. All right, we'll stick. In this course right here, we'll stick with two-column proofs. Is that all right with you? What's in the first column? Statements. No. Statements. Because it's not all given in the left column. And then reasons over here. All right. Now, a lot of times, in fact, I was watching a YouTube video of this teacher, and the first thing he said was, always put the given first. I don't always agree with that. Now, does that happen the majority of the time? Yeah, it does. All right, but I wouldn't always say put all the given first every single time, even though we normally do that. All right, and there'll be some times, maybe not today, but there'll be some times, some other times where we might not necessarily put the given first. It may not really flow in a nice order by putting the given first. In this one, it does. So we'll put the given first, okay? So I'm going to put, let's go this one equals this one. So AB equals CB. All right? And that's given, isn't it? Look at the next one. AD equals CD. So let's put that down here, and we'll just put one reason for both of these since they're the same reason. A lot of times they'll number the steps. I don't really care if you number them or not. A lot of times you'll see that though. All right, so they number the steps. So that's step one. And what's my I gave it away. What's my reasoning for this stuff right here? It's just given. All right. Now again, I would say the vast majority of the times when you do a proof, you put the given first. But there are times when it doesn't really make sense to put the given first. You'll see that later on as we do some more. All right. What's the next thing we did? Okay, we got. If you want to, you could do this. Sometimes I like to do this. That's not an angle. It's not an angle, is it? What is it? It's a side. You don't have to do this, but I like to do this because it shows me what I already know. So that's one of my sides. What's this right here? That's one of my other sides, right? So far, what do I have? I got two sides. How many do I need? I need three. All right, so where's the third one? This will be step 2. Yeah, BD. So what do we say? BD equals what? BD. Very good. All right, that's my third side, isn't it? You see it? And now it just flows. Do you see how nice it is to put that right there? Because now I can see, oh, side, side, side. Right? That's kind of nice, isn't it? So what's my reasoning for this? It's up there on the thing. Yeah, reflexive property. So just write, even if you just write reflexive, I'm fine with that. You don't have to put the word property. Just put reflexive. I'm good with that. All right? So look, side, side, side. Now, I've got enough information now to say what? That my triangles are what? Congruent. So let's write it down. So triangle ABD is congruent to triangle CBD. It's supposed to be a D. All right? What's my reasoning? So far, today we only have 2 ways to prove triangles congruent, right? And the first one was, say it? Side, 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 okay? And that's what this is. And side angle side's the other one, but we don't know anything about any of the angles here, do we? So the only way we can prove this is by side, side, side. And that's it. Your proof is done. We're finished. All right? Watch. Q, E, D. What the heck is that? Yeah. Actually, I saw this on a YouTube video. I was surprised to see that. I didn't listen to it. I should have listened to it to see his explanation. But in college, this is what this guy would do after it. It's Latin. I don't know exact. It's something like quid est demonstrantum or something like that. I don't know Latin, but it means as was demonstrated. So it's like, you know how at the end of a movie, especially old-time movies, it'll say the end, you know. This is kind of like the Latin version of a proof, meaning what? The end. We're done. That's it. We're finished. I don't usually put that there, but I just thought I'd throw it in there just to show you. But it does happen. It's not a joke. It's not a, I'm not I don't know why you're laughing. I mean, whoops, missed the E. Yeah, it's kind of weird. I understand, but I mean, it's nothing to laugh about. So QED means, as was demonstrated, QUED. Yeah, some people say QUED. Yeah, I had a class a couple years ago. That's all they said. After everything we did, every time we answered a problem, every time, it wasn't even a proof. Every time we did something, the kid would always say, QUED, QUED. I'm like, whatever. It kind of got on my nerves after a while, so if you want to get on my nerves, there you go. All right, that was easy. Would you agree? Hands up. Easy or not? Yes? Yes, easy. See, I told you. I wasn't lying. I don't say everything's easy. Well, I just said it's easy. All right. All right, let's do another one. And we got some time. I may let you do this one. Let's pause this. I'll draw the picture, then I'll let you try it. Yeah. All right, here's our situation right here. I've got two triangles, got it labeled, got all the stuff that's given. So the first thing we're going to do is we're going to mark the triangles. So HF right there is equal to HJ. All right, so those two right there are equal to each other. FG, this one, is equal to JK. Now some people may look at this the way I drew it and say, oh, this one is equal to this one. Kind of looks like it, doesn't it? But is that necessarily true? No. All right, I've never said that these two are equal to each other. All right, but this one on the end and this one on the end are equal. These two in the middle are equal to each other. What else did they tell you? H is the midpoint. So this point right here.
This means they are equal.
That's right. H is the midpoint of GK, which means that what? And give me a reason though. You always have to have reasons. It's not the reason that this side is equal to this is not because of side. You only use that to prove, listen to me, let me finish my statement. You don't use side to say that two segments are equal to each other. You use side to say what? That two triangles are what? Congruent, okay? So we're not at the point where we're trying to prove the triangle is congruent just yet. I'm asking you, why is GH, and it's true, it is, why is GH equal to HK? If we know that this is the midpoint, why is this equal to this? Somebody give me a reason. Say it, I can't hear. It's in the middle.
It's exactly 1/2.
There's no midpoint postulate, but there is something about the midpoint that we discussed. Say, who said it? Definition. It's the definition of the midpoint. What's the definition of midpoint say? Now you don't have to know it exactly word for word, but basically if I said this is the midpoint right here, what did you say about these two sides? They're equal. That's what the definition of midpoint says. The midpoint splits a segment into two equal segments. Isn't that what this point's doing? Yeah. So why is this segment equal to this segment? Because the definition of the midpoint says that it splits it into two equal segments. Does that make sense? We use that a lot. We use definitions of words quite a bit. So if it says this is the midpoint, why do I know this and this are equal to each other? Because the definition of a midpoint. Go ahead. I thought you were raising your hand. Okay. All right, so now, Travis, now you can tell me. Look, I've got one set of sides. I've got two set of sides from here to here, and then I got three set of sides. So tell me something about the triangles. They are what? They are congruent, and what's my reason? Side. Okay, so let's real quick sketch the proof out right here, and because I want to do a couple more before class is over. So I'll just put S and R. You write statements, reasons. I'm just doing this for the sake of time. So let's do it. Let's do the two sets of sides first, and it's given, isn't it? All right, so HF equals HJ, and FG equals JK, and that's given. Now, can I go right, and that's one side, isn't it? And that's another side. Can I go right to the fact that GH equals HK? No, I can't. I got to say something. How did I figure out that this segment and this segment were equal to each other? Because H is the midpoint. I have to say that first. Everybody follow me? I have to say that H is the midpoint before I say that this segment is equal to this segment. So, H is the midpoint of GK. Now I can say what? That GH equals, yeah, I'm going to go KH, is that all right? Because they're the ones that actually correspond to each other. And what's my reason for that? Definition of what? Of midpoint. Okay? And that's my other side, isn't it? Look what I got. I got side. Tell me something that's true about my triangles. Triangle FGH is congruent to triangle JKH. And what's my reason? Side. QUED, right? All right, that's it. Let's do another one.